request response, but then we also add in a next. And this is an arrow function. Inside this function, I'm going to console log and just say attempted to load hello.html. And then after our console log, or our call to the console log, we call next. And what that does is it moves on to the next handler or the next expression. And you won't see this often, but you can put a comma and then just put the next function right afterwards. So here we'll have a request and response. We could have a next if we were going to chain another one after this, but if this is the last one in the chain, it won't have a next. It would just be the request and response. And here we can response.send, and we'll just go back to our hello world message that we had at the very beginning. And if we save this, we'll go ahead and be able to see the console at the same time. Let's pull up Chrome. And over here, we'll go ahead and request the hello. And now we get hello world in our small text in the browser. And we also got our console log message attempted to load hello.html. So you can see we're calling one function, and then when next is called, it goes on and calls the next function in the chain. Now let me show you another way that you might see functions chained together. Paste request to go ahead. You can handlers are provided right here in this simple line, and we're called chain top, and in the where currently today we'll learn about middleware in the Express.js framework. We're going to start out with the code repository from the last tutorial, but if you don't have it, you should be able to easily follow along without it. Or you can download or clone the starter source code from the link I'm providing in the description below. So what is middleware? It's really anything between the request and the response, so the route handlers we created in the last tutorial are really middleware too. And we can see one of those right here that I'll highlight on the page. We've got a route handler for the new page route, so you could consider this middleware. And of course, we covered different things you can do with these route handlers, including chaining them. As we see right here, I've got a route handler, a comma, and then a second handler, or we chained them in an array by creating 3 separate handlers here and then putting them in an array in the route right here. So just a little bit of a recap, but those are overall considered route handlers, even though they are essentially middleware. So what about creating some specific middleware, where there are 3 types of middleware? There's built-in middleware, there's custom middleware, and there's middleware from third parties. Of course, the custom middleware is what we create ourselves. So let's get started with the built-in middleware. I'm going to create some space right underneath the port definition, and I'm going to paste in some built-in middleware. And the first thing we should notice here is that it is app.use. And app.use is what we often use to apply middleware to all routes that are coming in. And of course, just like our HTTP methods, get, and of course we could use post, delete, put, and other methods as well. Just like those methods, this all works as a waterfall. So if we put app.use above our routes, then this will apply to all routes that come in. And you can see in here, we're calling express.url encoded. And then this receives an options object, there I can say it, and extended is set to false. And that's usually how you see it. You can look in the documentation if you want to dive deeper into that, but that is typically what you see. So what is this middleware for? Well, it's for handling URL encoded data. In other words, form data. So when that comes in the URL, then you can pull the data out as a parameter. So we need to add this middleware that is built into Express in order to get that data when form data is submitted. Now I'll add an additional layer of middleware, and this is for JSON, as you might expect. So not form data, but if JSON data is submitted, we need to be able to get those parameters or that data out of the submission, and we use this middleware to do it. So once again, app.use and then express.json, and now this is applied to all routes as it comes in. And finally, for the last piece of built-in middleware that we'll apply today, we're going to serve static files. And this is important because if you remember from the last tutorial, we were not yet applying CSS. We had a broken image in our new page, and files that should be available to the public were not available. And that's what this middleware does. It serves static files. So once again, we start with app use, and then it's express.static, and we supply the path. And here I'm using path join, as we have many times before. We supply the directory name value, and then the public folder is what we're going to put all of those in. So when we save this, we now need to create a public folder. And inside this public folder, we need to drag our CSS folder, and we need to drag our image folder. And let's go ahead and create one more folder in here, and let's call this text. And then from our data folder, let's pull down the data.txt and put it inside the text folder. So now we have some files that we want readily available for the public, and Express will automatically route those files there because this is applied before our other routes. So it will search the public directory for the requests before it moves to these other routes. Let's go ahead and open a terminal window. From the terminal menu, you can choose New Terminal, or like me, Control and the backtick, and it opens up the terminal here. I've got a bash window, and that should work just fine. I'm going to type npm run dev to start NodeMon for our development server, and this should launch everything. And yes, we're already running on port 3500. Let's go to Chrome. And I've got a blank window open in Chrome, so we can type localhost 3500 was already there, and we get index, and it's already applying the CSS. So now let's go ahead and comment out the middleware. So we're not using those static files, and let's reload our index page and see what we get. Now there's no CSS applied, so it is absolutely finding those public files and applying them. However, we didn't really change the path in those files, and we should. Now I'll reload this, and we do see it's applied. But let's take a look at those files. Here's our index, and we were going up out of the views directory and then into the CSS directory, and that's not really there, so this is being a little forgiving. Let's just get rid of that because we know this path is available to the public, of course, after the directory name there. So after the root of the URL, it should just be css/style.css. And we can double check that by going to Chrome, and from there we can just type /css/style.css. Sure enough, we pull up our CSS file in the browser, so it is available to the public. Let's go ahead and make these same changes on our new page.html. We can get rid of the .. for image, for the image directory and for the CSS directory, and save that. And also in our custom 404, we can get rid of the .. and save. Now all of those should be working fine, and they really were before, but this cleans it up. Now let's go back to the server.js, and let's consider adding some custom middleware that we write ourselves. Let's create a custom logger, and we want it before anything else because we could put it, I guess, after the static files are served, but then we would not log the requests for the CSS or the images or anything like that. So if we put it at the very top, then we'll see the requests for everything as they come through. So we'll just call this custom middleware logger. And now we'll start with app.use. And inside of app.use, we'll put an anonymous function that gets a request, response, and since we're creating this, it needs to have next so we can move on. Notice the built-in middleware did not need next called. It's already built into that, but we need to call next inside of our custom middleware. So let's log to the console inside this logger, and we'll go ahead and log the request method. Here's the request.method, and then give a space, and we'll log the request.path as well. And now with both of those sent to the log, the only other thing we need to do is call next. So let's save this, and now let's go back to Chrome, And we can still see our console here. Let's request the page. And you can see we get the get request here, and there's the slash, which is the home page. And we also see the request for the CSS file. While logging to the console is okay for our middleware logger, what we really would like to do is create a log file. And we've already created a log events function back when we were working just with Node. So we can go ahead and use this log events function in our logger as well. Let's create a new folder in the file tree and call this folder middleware. From here, let's pull the log events.js file straight into that directory. And now that we have log events there, we really don't need to change much, and we are already exporting log events as well, so that's good. What we will need to change is where it writes the logs, because we don't want it to create a logs folder in the middleware folder. So with our path.join, what we need to do is add in one extra spot here. I did not mean to hit return, there we go. And just go one directory up with the two dots. And now that we've got that, I'll copy it, and we need to add it to this path and this path as well. So when the logs directory is created, it is here where we already have our logs directory from the past, rather than being created in the middleware directory. And now we need to take log events and import it into our server. So we'll scroll to the top, and let's just put it underneath path, and we'll say const log events equals require dot slash middleware slash log events. And that completes that. We can save. And now we can use log events inside of our custom middleware logger. Let's put it right above the console log, and we have log events. And log events accepts two parameters. The first is the message, and the next is the file that it should write to or create. So inside for the message, we'll create a template literal, and I'm just going to paste this in so you can see the full message. It is the request method, and then we put a /t for tab, so we have a tab delimited log file, and then it's the request.headers.origin, which should be saying where the request is coming from, what website sent it to us, and then we should get what URL was requested. So say it's a get method and the request is coming from google.com and they are requesting our index page. After that, we need to tell it what file to create or write to, and we'll call this rec for request.log.txt. And now we should be good to go with our log. Log events function. Let's go back to Chrome one more time and let's go ahead and request our index page. It was requested. We see the requests here, and now we also see a request log has been created, and there are two requests. It was a GET request both times, and it was undefined because we're just running our Node server right here on our local host. And you can see what was requested as well, the slash for index and the CSS style.css. And while this works, once again, let's look at the server.js. While this works, we're really importing a function to use inside of our anonymous function that is our logger that has the request, response, and next, as any middleware should. So we can clean this up a little bit. Let me go ahead and copy the anonymous function and everything inside of it. Control C to do that. And now we'll go back to the log events.js file, and here we can define another function just called logger. We'll set that equal to this anonymous function, and now logger can be our custom middleware that we export. So down here, instead of just exporting log events, which we'll use later or we wouldn't need to right now at all, I'll go ahead and put both inside of curly braces. Once again, we won't be using log events anymore inside of the server.js though. I'm just exporting this for use later when the need arises. So back at the server.js, instead of log events, we'll need curly braces now that there's two functions being exported, and we'll import logger from the log events file. And now with logger being imported and all of this logic inside of logger, we can just say app use logger. And now this is much cleaner and should still work in the same way. So let's pull up Chrome once again and let's request the index. And we see the console logs still work. Let's look at the request log. And yes, we have two more requests in the request log. Once again, notice that it says undefined here as the origin because we're just using our local host server here as we pull this up. So let's make a request from another domain. I'll pull Chrome back up and now a new tab, and we'll go to Google. And on Google, let me go ahead and expand this and open up the DevTools with Control-Shift-I. Now that I have DevTools open, what I want to do is just call fetch, and I'm not really interested in the data. We're just going to fetch the destination, and let's see what we get. We get a CORS error. It says no access control allow origin. But let's go ahead and check our log file, and our log file does show google.com as the request origin. So you may have seen that error we got before from Google that showed the CORS error, and that stands for cross-origin resource sharing. And now this will lead us to third-party middleware, so we can install a dependency. I pressed Control-C to stop our dev server. I'm going to type npm I for install, and then CORS, C-O-R-S. And this should take just a second to install, and we'll be able to see the new dependency in our package JSON when this is finished. And it says it's finished already. Let's check the package JSON, and here we see CORS now added as a dependency. So let's go back to the server.js file. Okay, so we're in the server.js file here, and we need to go ahead and import CORS. So we define CORS and set it equal to require CORS. Once we have that, we need to apply the middleware. So we want it to come as soon as possible, but after the logger. So let's go ahead and apply CORS here. So we'll say app.use, and then we can just call CORS inside of the app.use. I'll go ahead and put a note here that CORS stands for cross-origin resource sharing. Let's save that and now go back and start our dev server again with npm run dev. And once the dev server has started, we'll pull up Google. It says it's good to go, it looks like. And Let's go back to Google and let's make the same request. And now there's no CORS error. We get a promise pending, of course, from fetch, as we expect to there, but there's no error. And that's the main thing, is we can request data now from the google.com domain, and it doesn't create a CORS error. Let's minimize Chrome, and let's look at our request log again, and we once again see Google in there. So the domain, the request origin, did come from google.com. Okay, now let's go a little deeper into CORS. I don't want to make this a full tutorial on CORS because that can get pretty deep. However, CORS for cross-origin resource sharing is something that does need to be applied, or you will get those errors. However, this just leaves it open. If you had an open to the public API, this would be fine. You're using CORS and everyone can use it. But for many applications, that's not really what you want. So let's create a whitelist, and we'll define it with a const, call it whitelist. And inside of that, we can have more than one domain. So let's say https / and then www.yoursite, whatever your .com is, whatever application, web application domain that will access this back-end Node server. That's where you want to put this domain here. But say you might also have a variation. Maybe you've got a variation without the www. Or maybe you're working on a local dev server and you launch from go live down here, click to run live server. Live server always runs on http://127.0.0.1, which is your computer, and then it gets a port like 5500, I believe, is the default. So maybe as you're building a React app, you're running your React app on this port or a different port on your local host, or you've used the IP address, which 127.0.0.1 is the same as having localhost there. Anything like that. So let's add those to the whitelist, and of course we should add http://localhost, and we're using 3500 here today. Now you would take these out after development, but of course you would leave in whatever domains should be able to access your data or your back-end server, and that would be your web application. Say your React application is at whatever domain, you would leave that in here. So we've created a list that is allowed to access the back end that CORS will not prevent. So now we need to create the function that will allow CORS to do this. And this is all contained within the CORS options. So that's what we'll call this, lowercase CORS and then camel case here with a capital O for options. And we set this equal to an options object. And the first property is origin, and origin can accept a function. So we have an anonymous function here, and it gets the origin, which is not the same as the origin right here necessarily. This is the origin coming from whoever requested it, say google.com, and then a callback function. And again, the two origins, a little confusing, but it's right from the documentation, so that's kind of how we need to do it. So we've got the origin there with the anonymous function, and we can say if the whitelist dot index of, and then we pass in the origin that is passed into the function. If that index is not equal to -1, in other words, if the domain is in the whitelist, then we're going to go ahead and let it pass. And then we can do the callback, and the first parameter in the callback is null, which is usually the error. So there's no error, and then we set the second one to true, and that just means that the origin will be sent back saying yes, that's the same origin and it is allowed. And then we can have an else, and in the callback here we have an error instead of null, and we create a new error, and we can just say not allowed by CORS. And so that is the message to go along with the error. Now that is the first property here in the CORS options. We need to add one more, so we put a comma, and then we put lowercase here, options / success status. There it is. And we send a 200. And with that, we can save. And now that we've created the course options, we need to pass those in right here. And notice we did not include Google in these course options. Now Google could access without an error before we put in the options. Let's go back and make the same request from Google and see what happens now. We once again have a course error. So let's go back and let's go ahead and change your site to google.com. Server is restarting. It looks like it's hanging up. Nope, it's going to go ahead and do it. There, we got it. And we go back to Google once again, and now it's in the whitelist, and we fetch, and there is no error. So we know our function is working as we expect it to. So when we come back and look, once again, you could change this to your domain, whatever your project, wherever it will be hosted. Say you've created it in React or Vue or even vanilla JavaScript, Svelte even, whatever you might create a front-end project with that will access this back-end, you want to put that domain in here, or maybe variations of. Again, remember, you might not have the www, or it might be optional, anything like that. So that allows you to put in domains that can access the routes, and otherwise CORS will prevent them. So very useful third-party middleware. I want to go back to Chrome one more time and create that error one more time now that we've taken Google out of the whitelist. At least I thought we took Google out of the whitelist. Maybe I didn't save after we did that. That's exactly what happened. I hadn't saved the server.js file yet. Save here. NodeMon is restarting. It's taking it just a little bit. Maybe I need to go ahead and restart it once again. Every now and then I have to restart it manually. So npm run dev, get the NodeMon server up and running. I'll pull up Chrome, and let's see if we can get that error again. So yes, we've got the CORS error here. Now let's look back in Visual Studio Code as well. And you can see we got the server still running, but we got this big error. And up here it says our message, error not allowed by CORS, and this huge error here. Now we can handle errors in Express as well, but Express is already handling them. It has the built-in error handler by default, and that's what's happening when we throw this error. It is going there. However, let's go ahead and add a little custom error handling. So we scroll down to the very end. Remember, it's a full chain, so we want this after everything else, even after our 404 here. I'm going to paste this in, and you can see I'm using app use once again, and then this is an anonymous function, and it doesn't just get the request, response, and next, it also receives an error parameter. And then we can log to the console the error stack if we want to, or just the message or whatever. We can go ahead and send a status 500 server error, and we can send the message to be displayed in the browser. So I'm going to save this, and we'll go back to Chrome, but we won't use Google anymore. Let's go ahead and just use the page that we have here, and I'll see if I can resize. There we go. I'm going to reload. And look, we got a not allowed by CORS, even though we requested our index page. But our custom error did work, and it sent this to the browser. Now, why did we get that? Well, let's go ahead and look at the log. Here's our request log. You can see it's once again undefined. So undefined is a problem because that's not in the whitelist. So during development, you want to go ahead and make one modification to this function. Right here, after the -1, go ahead and put in the OR operator and then say no origin, essentially the exclamation mark origin, which would be the equivalent of undefined or false. And we save that, and now it should work. Now, after development, we probably want to remove that as well, just like we want to remove some of the development URLs that we have up here in the whitelist. So now let's go back to Chrome and see if we can reload our index page. Yes, and now everything is working as we expect it to. Now we can also tidy up that custom error handler. So let's scroll back down to it, and we see the function that we have here inside of app use. I'm just going to copy that complete function, and now inside the middleware folder, let's create a new file, and let's call this error handler with a capital H there. So camel case, error handler.js. And now let's define our error handler and set it equal to, and we'll remove the function keyword, and we'll go ahead and put an arrow after this. And we've defined our error handler, but what we want to do that we're not doing yet is also create an error log. And this is where exporting the log events function that we left here comes in very handy. So now we need to import that here, not the logger, but the log events. So let's define log events inside of the curly braces, set that equal to require /log events. And now that we're importing log events, we can go ahead and use that in the function as well. So we'll call log events right here before we log to the console. And once again, this function gets a message first and then the name of the file that it needs to write to or create. So this will be a template literal, and I'm just going to paste in the values once again. Here, instead of anything from the request, such as the method like we were logging before, we're going to log the error name and the error message. And then we'll put a comma and go ahead and specify error log.txt as to where we want to write the error to. And we can save this, but we're not quite finished yet because we need to export this function. So we do module.exports, set this equal to error handler, and now save. And now we need to import error handler into our server. So let's scroll to the top of our server.js, and right underneath logger, I'm just going to go ahead and copy this down, and let's change this to error handler. And instead of log events, we're importing from middleware error handler, and save. Now we need to use the error handler where we previously had the larger function in this file. So it will be much cleaner. So let's go ahead and select this full function, delete that, and paste in error handler. And we can save. And we got an error, the app crashed. Let's see what we've got. So if I scroll up, it says app.use requires a middleware function. So something about the function probably didn't get imported correctly. Let's go ahead and scroll up to the top and look at our import statement. And oh yeah, we were using curly braces around logger because it was one of two functions from the file, but from the error handler, it's the only one. So let's go ahead and remove those curly braces around error handler and see how everything goes. It's restarting the server right now, and server running on port 3500. That part looks good. So with the server running, the best way I know to create an error would be to go ahead and remove this or no origin for now, and we'll go ahead and save, and then we'll try to reload the index page once again in Chrome. So it's starting the Node.js server, and now that it's running, let's reload, and we've got a not allowed by cores as we expected, an error in the console, and now we have an error log file over here in the file tree, and we can see we got our error not allowed by cores at 1827. So let's go ahead and look at the request log, and we should be able to line that up with what request happened here as well, and we can. So everything there is working as expected. So now that the error is logging, let's go ahead and put that or no origin statement back in for now, so we do not keep getting rejected by cores. We can go back and we can once again request the index page, and everything should work well when the server restarts. There we go, we've got the index page now. Okay, there's one more thing to do before we're finished today, and that is to compare app.use to app.all. And that's what we're going to do right here as we change up the 404 just a little bit. So with app.use, we could do something like this, app.use, and specify here at the end of the chain everything. Let's for use or that route more JS. Today, we're going to talk about creating routers in the Express.js framework. And we're going to start out with the code repository from the last tutorial, but if you don't have it, you should be able to easily follow along, or you can download or clone the starter source code from the link I'm providing in the description below. All right, in Visual Studio Code, we've got our server.js file. And from the previous tutorial, we've got a lot of code in here. And really what we can do is break these routes out into individual routers that are essentially mini servers for each specific route, or mini apps. As we create our app with Express here, these will be mini apps and we'll refer to them as routers. So over in the file tree, let's create a new directory and let's call this directory routes. And now inside the routes, we can create routers for each route that we are handling. So let's create a new file here and let's call this subdir.js because we have a subdir directory in our views folder that we haven't handled at all yet. Now in the subdir.js, we need to start out with a few requirements once again. And the first would be Express, just like we did in the regular app, or server.js, if you will. So we have require Express, and then after that, just like we have before, we have applied Express. However, now we'll define a router instead of an app, and we'll set this equal to express.router with a capital R. And then we're going to go ahead and need the path module as well from Common Core module in Node.js. So we'll require path. After that, let's just go ahead and put our module.exports and set that equal to router, because that's what we'll always do when we create a router. And then we can import that back in the server.js when we need it. Now we're ready to just pull our routes in. So let's look at the server.js and the routes that we had or did not have at this point for the subdirectory. And I don't believe we had any yet. We were just routing to our specific views for index and the new page. And of course we were redirecting the old page. So we hadn't handled anything for the subdirectory yet. It has its own index and it has a file called test.html. So I'm going to copy how we handled the index for the root, and then we can just modify that in the subdirectory. And instead of app.get, we now have a router. So let's replace app with router. And now it's router.get. And then we can handle the slash or index for the subdirectory the same way we did for our root. And we have a request and response, and we can remove this commented line that we had in there before. And then we are sending a file, and we're sending the root directory. We get the directory name here. And then we want to have views, but now we have to think about this because we are not inside the root, so we can't just look directly into the views directory. So we need to come up out of the routes directory we created and then into the views directory. And then we're not only just looking for the index, because that would be the root index. Now we need to specify the subdirectory that we have, and then the index.html that's within that subdirectory file. After that, let's copy this down, and I can press Shift Alt and the down arrow. I'm using Windows. It may be different if you're on Mac or Linux. And now we have another get route, but this will be for the test.html. And so we can replace index with test and remove the initial slash. We'll leave the HTML optional. This is regex that we can use within the route. And now we're sending a file once again, but instead of sending index, we're sending test, not text.html. And we can save that. Now that we've created the router file for the subdirectory, we need to go back to server.js. And underneath where we serve the static files, and we set that, we need to go ahead and provide a route. And we do that with app.use in the server file. And now let's provide the route that we are providing the router for. And then we can go ahead and require the router that we have created. And now this will be in ./routes/ and there's the subdirectory. And after we provide that, We should be finished, and now this will route any request coming for the subdirectory to the router instead of the routes that we are providing below through app.get, such as index and new page. So this will match in front of these. And of course, we can put all of these in a router, and we will next. But let's go ahead and start the dev server. I'm going to press Control and the backtick, but you can go to the terminal menu and open a new terminal window. And if you remember, we type npm run dev, and this will start our local dev server with NodeMon, which will listen for any changes, and it's on port 3500. So let's go to Chrome, and I'll go to my blank page. I'll type localhost port 3500, and there we've got our index file, and that's fine, but we want to go to the subdirectory and see if this is working. So we've got subdir. And yes, we've got our subdirectory index page. And let's go ahead and see if the test index page in the subdirectory is also working. I said index test.html actually, and there's our test page in the subdirectory as well. Okay, now let's ask for a page that does not exist in this subdirectory, and let's see what we get. Well, we got our 404 page, but there's something important to notice here. In the past, when we've got our 404 page, it had CSS supplied for it. Now, we didn't put CSS on the previous subdirectory pages. That was not included anyway. But if we requested a 404 on any other page that was not in the subdirectory, it does have CSS applied. So why is the CSS not working for our subdirectory? Well, it's because we haven't told Express to use the public folder or public directory, if you will, for the subdirectory. So let's copy this line down with Shift Alt and the down arrow once again. And now we can specify the subdirectory here and tell Express to use that public directory. Before, we didn't supply a directory, but the default is the slash anyway. And so that's essentially what we were doing. But we can save these, and now we should be able to go back and request our 404, basically any page that doesn't exist in the subdirectory, and probably get the formatted 404. Yes, now, even though we're in the subdirectory and I requested a page named Dave that doesn't exist, we got a 404 that actually has the CSS supplied. And you can even see the request coming through down here for the CSS in the subdirectory, and it now works. And I'd like to make one quick correction from the last tutorial. that I did provide information that was correct in older versions. However, in newer versions of Express, Express does support regex inside of app.use, and I said it didn't when I compared app.use to app.all. But now you can have regex there. And so if we are to require a router and we put a slash with an asterisk here, this would supersede the subdirectory router. In other words, all routes would go to this router if we supplied that. Of course, we don't want to do that, so we want to specifically state just the slash, or we could even get more specific and we could say, hey, it must start with the slash and it must end with the slash. And then, of course, we would only be providing that for the slash right here, but that is because it supports regex, and in previous older versions, Express did not support regex inside of app.use, but in the route it now does. Let's go ahead and create a router for this root directory here. So let's say /routes/root, and now I add the semicolon, one more over, and save. And now we need to go ahead and create this route because right now it doesn't exist. So let's go over here to the file tree. I'll collapse the views folder. We don't need to see what's open there, but inside of routes, let's go ahead and create this root.js. And now inside of the root.js file, let's go back to server and grab the routes that we were using for the root. And we have our index page, our new page, and a redirect for an old page. And Control X will cut those out and we can paste those inside of the root, but we also need those imports and basically everything you would normally start out with for a router. These three imports at the top: Express, router, and path. So we'll put those at the top of root as well. And then at the bottom, once again, you want to have module.exports and set that equal to the router. Now, what haven't we changed yet is the keyword app here that we were using in the server.js. We need to switch to router as well. We can once again get rid of this commented file, and we have to once again consider the route that we're providing because now we're in the routes folder. So yes, we have the directory name value, but then we need to come up out of the routes folder and then look in the views folder. Now this will be correct now. We're not looking in a subdirectory, so we no longer have to provide it there. Let's go ahead and copy this and paste it into the route for the new page as well. However, the route for the old page is a redirect, and this will be okay to leave it as it is. So let's save the root, and let's go back to the server. We can also get rid of some of these examples of route handlers that we had, such as the hello right here, and the chaining, the route handlers that I had previously provided for the chain route. Let's just delete all of that to clean it up a little bit and save our server.js. It's now restarted, so let's see if these routes are now working with the new router. And we'll come back and just go to the root. And yes, we got the root page. Let's go to /new-page. HTML should be optional, and there's our new page, and our image is working, which means we're getting our static file routed correctly to the public directory where the image is stored. And now let's go to old page and see if the redirect still works. And yes, we redirected back to the new page. Let's go ahead and type in index instead of just the slash. And yes, we still get the index page. Everything in the new router for the root is working correctly. With our routes working correctly, let's talk about how we would set up an API, or a REST API, if you will. And that's what is more important when we're working with, say, the MERN stack, as say Mongo, Express, Node, and of course React on the front end. Or you could substitute any database technology for Mongo, but we've got Node and Express here. And we want to organize a API, which is what we would more than likely create with Node and Express, say, compared to a static server for web pages, although you can do that. It's much more likely that you'll create an API, and that's what we'll focus on here. So underneath these routes, we're going to create one more route, and this will be to employees. And then inside of routes, it's going to be in a subfolder named API and then be employees. And notice this will just be routed by the user going to employees. They will not have to type API. So let's go ahead and save this, and then let's start creating that route. Inside of routes, we want to create another directory, and that's API. And then inside of the API, we want to create our employees router, and that's employees.js. Now up here inside the data folder, we've already got a file named data.json. Let's go ahead and rename this file, and let's call it employees.json. And let's give each employee inside of this file an ID, and we'll just make these chronological. So we've got 1 and an ID of 2. And now that we got that, we can just go ahead and save our small employees data file. And remember, that's employees.json inside the data folder. And we've created the route here inside of server using app use. Now, it does not need to have any static files, as we'll just be delivering JSON data from our API. So we wouldn't typically have any static files like we would with a web page. So now let's go back to our employees.js route. Let's start out our route just like we did the others. So we want to define express. We'll set this equal to requiring express. And then we want to go ahead and define our router once again, and we'll set this equal to express.router with a capital R and call router into action. And we'll once again need the path, Common Core module from Node.js, so we can require path. And after path, let's go ahead and define an empty object named data. And from there, let's set data.employees equal to require, and now let's get that JSON file. So we need to go up out of the API folder, and then we need to go up out of the routes folder, then into the data folder, and then to get employees.json. And so this is kind of like connecting to a database. This is just what we're doing for this tutorial and dev. Of course, in the future, we'll work on connecting to Mongo. And of course, you could replace that with your database technology of choice. But once again, just for this tutorial, just for dev, we're just going to import some JSON to simply work with here. So now let's go ahead and create our module.exports and set that equal to router again, as we always do with a router. And now we can set up our routes. Now, instead of just saying router.get and creating another router.post and another router.put, and of course putting those paths in there like we could, one thing we can do is say router.route and then provide the route, and then we can chain the different HTTP methods that we want to provide for this same route, as a GET request and a POST request can both go to the same route, but there can be a different result for each. So let's handle the GET request first, and here's a request and a response. And now inside the handler of the GET request, let's just return JSON, and let's return all the employees. So that will be data.employees. Now for the POST request, we can just come down here and say .post, and once again we can have a request and a response. We can handle this completely differently for the HTTP method POST than we do for GET. And now with the POST, we'll get parameters coming in to the request, and we can refer to those parameters with request.body and then whatever the name of the parameter is. Now we had a first name and a last name, and a POST request would be posting a new employee. So what we want to do, I'm not going to put in the full code that we would have in an API at this moment, because it's not really about coding an API right now. We're handling routes, so we just want to see how each one of these would work. So let's say the first name that we return in the JSON will return what is sent, and that's request.body.firstname. And then let's go ahead and return the last name as well. That's request.body.lastName. Once again, not writing out all the code for an API at this point, just showing how we can get the parameters from a post request, and then we're just sending those parameters back. But this is how we could handle each route in an API. Now let's go ahead and do the same thing with a put request. We have a request and a response, and this would be the HTTP method that you would use when you're updating an employee, for example. But we could do the same thing. We could get the res.json here, and as a matter of fact, I can just copy this down. And of course, the code would be different if you were writing an actual API, because you would be updating at that point. And we'll do that in the near future, just not going to do it yet. And then let's get a delete. Now, a delete would be different. We wouldn't be getting the first name and the last name. We would be getting the ID. So we'll just send the ID back in this case. And that would be response.json once again. Let's go ahead and send the ID back here, and this would be request.body.id. Now you can see we've chained each HTTP method together, and we've got get, post, put, and delete all coming into the same route on our router. They're just different request methods. And of course, this being the last one, we'll go ahead and stop right there. And I'm going to save this, but we're going to add one more route. We have the route coming in with just the slash, just the root, but then also we could have router.route and then a slash, but we could have a parameter directly in the URL. And that's what we're showing here is a parameter. And this would be a GET request that has a parameter inside of the URL. So now down here, and of course you could do that with other requests too. We're going to use a GET request. So let's go ahead and put the handler for our GET request here. We have our request and response. And now inside the handler, we'll once again respond with JSON, and we'll just say, here's the ID requested. And now this is different. Instead of request.body, it's request.params.id. And that's because we're pulling the parameter, it's a named parameter actually, and we're pulling it directly out of the URL. So here we're responding once again with just what we received, just as an example. Now I'll put in future code. We'll go ahead and actually code out an API. Right now, handling the routes. And so all of this is inside the router, and I guess we didn't need path right here at this moment, so we can get rid of that. But all of this is inside the router for employees. Let's go ahead and save this, and we can test it out. And our server is still running below, so we can now check these routes with Thunder Client. Thunder Client is an extension. In the past, I've used Postman, which is a separate program to test APIs. Let's go ahead and try this extension out. You can find it under extensions, search for Thunder Client, and it allows you to save different routes you want to test. So right here, I'm going to go ahead and choose the GET route that I created first. There it is for all employees, which of course there's only 2. And you can see here is our HTTP method, and here is the route. And now I'll click send, and here's the response. I can just make the response full screen, but we've got both of our employees returned. And that's exactly what we expected. So now after testing the GET route, let's go ahead and test the post route. So I'll choose that from our list. Well, let me go to collections. I believe I saved everything there. There we go. Let's choose post. And now we're once again going to the employees route, but it's got post. Let's look at the parameters and see if those were saved. And it should be under body actually. There we go. And I'm posting a new employee named John Doe. So let's see if we get that in return. We'll send that, and let's look at what was returned. Yes, we got John Doe sent back to us, and that's all we're going for today once again, as we're not writing out the actual code to add the employee or update the employee and things like that. In the near future, yes, I will. Okay, put should be the next one to test. So now it's a put method at the same URL. And once again, we are sending some John Doe. Oh, actually sending just the ID and the first name. of what we wanted to update. And of course, I think I had the put request just sending back the first name and last name. So maybe we'll just get the first name back. Let's see what we get when we test put. And yes, we just got the first name back, and that's what I expected. So that works also. Now let's test the delete route. Of course, it won't actually delete the employee this time around. And looks like we're sending just the ID, and we should get that ID back. Expand, and yes, in return, we've got the ID back. So that route is also working. Now there's one more get route where we could get a specific employee. And let's see if that one's here or here. Here we go. So this is our route with employees, but then it has slash and the number 1 where we're requesting just one employee, not both. So let's go ahead and send that and see what we get in return. And we returned the ID of 1. So that route is also working. And again, this extension is called Thunder Client if you want to check it out for testing the routes in your API. Now, as a challenge before my next tutorial, you could go ahead and write out the code to update the JSON that we were receiving. And of course, just hold it in memory. Don't really update the file, but you could test out what you want to do here for each of these routes, and you could handle each one of those. And I'll come back with some code for that in the next tutorial. And what I really also want to talk about in the next tutorial is organizing the rest of this API, including the server file, and setting it up, because after that, we'll pretty much be ready to connect everything to whichever database technology we would want to. So we'll organize this with an MVC pattern, that is Model View Controller. And of course, I can come back and add some extra code here to handle the API data just for the JSON as an extra test. It's not really anything to do with specifically Express. That's just JavaScript and handling how you would basically do CRUD operations: create, read, update, and delete. Today we will organize our Node.js and Express API server with the Model View Controller design pattern. You may have also heard this design pattern referred to as MVC. That said, remember, Express is by definition an unopinionated framework, and you can organize your project however you would like. I'm just demonstrating MVC because it's a popular pattern. We're going to start with the code repository from the last tutorial, but if you don't have it, you should be able to easily follow along without it, or you can download or clone the starter source code from the link I'm providing in the description below. Okay, we're right here in Visual Studio Code, and we've got our server.js file, and we want to use the correct terminology. So we were keeping our data inside of a data folder, and you can see I've renamed it to model. It still has the employees.json file in there, and we're just emulating a database here with a employees.json file instead of connecting to one at this point, because you might have MySQL or Mongo in mind or whatever. Later on in the series I plan to show Mongo. However, right now we're just going to simulate that connection to a database. And now besides that, we have a views folder. And really with a RESTful API, we won't have many views, if hardly one. Maybe we would have a welcome page that gives some directions about the API, but that's about it. We're not really serving a bunch of static pages or resources. What we will have though is a controller folder. So let's go ahead and create that. Oh, and I said controller, and really I should make this plural because it could host more than one. So let's go ahead and call this controllers, and it will hold controller files. So inside of here, let's go ahead and create an employees controller.js file. Now currently we have all of our logic really inside of our routes. So if we open up routes and the API directory and then look at employees.js, our logic is essentially the route handlers. So for router.route, and then we come to the get HTTP method, we've got this handler that returns all of the employees. So what we would want to do would be remove that logic from here and take it to the controller. So we could name this something like get all employees, and then we can just assign that route handler as a function. So now we have a get all employees function that is part of the controller. So let's save that. But what we also need here is the data. So the data that we were pulling in to the employees.js route inside the API is actually will need to be inside of the controller at this point instead of the route. We're breaking that out. And so we'll put that at the top of this file as well. So these functions can work with that data. So I'll save this again. And now back inside of employees, let's pull out the logic from the post. And here we go with that logic. And now we'll call this function a different name. We've got create new employee, and we'll set it equal to that action. And then the next function we'll go ahead and name as well, and that will be update employee. And we'll set it equal to what we find here in the put portion of this route. And now we'll come back and assign that to update employee. And finally, as you might guess, we'll have delete employee. And we'll set that equal to the handler for delete. Not copy, but cut. There we go. And we can paste that in here as well. Now I'll go ahead and save that. Now we're not finished with the controller by any means, but we have the first actions in here for these routes. And we haven't put anything back in here yet, but we will. But there's one more function to create here. And this would be called just get employee instead of get all employees. So let's go ahead and get this action as well, or route handler is what we could refer to those as still. And let's say get employee. And now we have all of these different functions defined inside of our employees controller. And of course, we're pulling in the data here at the top. But as you might expect, we need to export these as well. So we'll have module.exports. Let's set this equal to an object now. And so we had get all employees, and then we had create new employee, and we had update employee and delete employee, and then we had get employee. And so we're exporting all of these functions now. Let's go back to the employees.js routes and let's import our controller. So let's call this employees controller, and we'll set it equal to require, and then we have to consider where we are. So we go up a folder and then up another folder, and once we're there, now we can select the controllers folder, and inside there we find our employees controller. Now we could deconstruct those functions here as we import those in, but I think I'll leave the name employees controller because we're emphasizing creating a controller here, and then we'll just put in the functions. And in Visual Studio Code, I believe if I start typing the functions, it's going to import the part that says employees controller for me. And sure enough, it does. So now we can have create new employee and select that. And here we're going to have update employee. And finally, we should have delete employee, not this delete. We didn't quite get that right. Delete employee, there it is. And so all of these actions are coming from the controller, or route handlers, we could say. And this still doesn't look right. We've got a D in front of there. Employees controller dot delete employee. That's what we should have. And now here we should have get employee with the employees controller. So this definitely cleaned up our route file here quite a bit, and we've separated the logic into our controller. And that's really what the model view controller pattern is all about. And so we could do that with other routes if we had other routes as well. But now we've really cleaned up our whole project. Let's go back and do just a little more cleanup in the server.js, and we can get rid of some of these views that we're no longer going to use. One other thing I'd like to do is, you see we're pulling some things into the server file right at the beginning, and we're starting to use the logger right away, but we're taking up a lot of space here with cores, and we don't have any kind of configuration folder over here in the file tree yet. So let's go ahead and create a config folder, not JS, just config folder. And now we can go ahead and create a cores options.js file right there. And back in the server, let's go ahead and take our whitelist and cores options and cut those out of here and paste them into our cores options.js here. And I'm going to put each one of the URLs on its own line, just so it's easier to read. And after we define the whitelist at the top, we have our cores options. And as you might guess, we need to do module.exports, set this equal to cores options. And now we'll need to import this back inside of the server. So at the top of the server here, we could just put it right under cores, and we'll say const cores options and set this equal to require dot slash, there we go, config. And now inside of the config folder, we have our cores options. We can save that. Let's see if there's anything else we can clean up. I've got some extra comments in here. Of course, this being a tutorial, that kind of makes sense. Let's make them a little bit smaller. Just put form data besides that. And the routes look good. And we have our catch-all 404 here. And we have our error handler. And we have made our server.js much smaller. We're down to 44 lines of code, including some spaces here. And we have pulled that logic out into a controller. So that has really helped clean up, but we're really not going to need this example of a subdirectory anymore. So let's go ahead and get rid of that. And that means we can get rid of the app use for the static files in the subdirectory as well, and save that once again. And that means we can delete the subdirectory route from the tree. And we can also go ahead and delete the subdirectory over here in the views. And let's go ahead and delete the new page. And that means we can go into our root routes, and we will not be routing to a new page or an old page any longer either, and get rid of both of those. And now that's quite a bit of cleanup, but at least we still have our splash page for the index if we wanted to put some directions for our API there. And so we're handling that inside of the root route, and that's in our routes folder. And then we have our API directory, and that handles the employees routes here. Okay, with everything cleaned up, in the last tutorial, I promised to go ahead and provide the JavaScript code. This is not so much just dealing with Express or Node, but the code, if you were to have an API that was going to update not the JSON file, but just in memory, and kind of emulate an API before we've connected it to a database. So at this point, I can go ahead and provide that code. And if you went ahead and worked on the challenge that I said at the end of the last tutorial, you can compare your code to what I did. I'm just noticing I didn't change the path to the data folder here either for the employees, because really it didn't need to come up to anymore. So you would just come up out of the controller folder, and then you're not even going into a data folder at this point, you're going into a model folder. But I'm going to change this, all of this now, but I wanted to say that correction about the path. And let's have the data object set like this. And if you work with React, I'm thinking in more of a Reactful way when I do this, but I've got the employees data set, still pulling it in and just setting it directly to the employees property of the data object. But then I've got a set employees function here as well that I'll use inside of these other functions. Now, as you might expect, get all employees doesn't really need any extra work. We're just returning all of the employees by referencing data.employees, and that's fine. Now, to create a new employee, I'll paste in my code and we can review it. There's a little bit more work there. So when we get a new employee, we want to create the new ID, and instead of importing a package like UUID or something like that, I'm just grabbing the last employee in the JSON array, and I'm adding 1 to the ID that exists there, whatever the last one is. So of course I need to make sure they're in chronological order, which will come into play later. But that's what I'm doing here. Other than that, first name and last name assigned to the parameters we're getting from request.body, and then of course it's first name and last name. After that, we're making sure that a first name and last name are sent, and if not, we're sending a response 400 saying, hey, we didn't get the required data. After that, I'm using the set employees function to go ahead and set the employees to the new information. And of course, the new employee is at the end of the array. And I'm just realizing here I didn't send a different status when we send the employees back. And I'm sending all of the employees instead of just the new ones so we could see the update. But here we could also send a status of 201, which means it created the new record. And we'll go ahead and save that. Okay, update employee gets a little more complicated, but it's not too bad. So let's go ahead and paste this code in and review it. So here we grab the employee if we received an ID as a parameter, and we should because we're updating an existing employee. And if the employee does not exist, we're returning a response status 400, meaning we did not get good data to update. And we have the message here as well, employee ID is not found. And that would be the end of it if we didn't get an ID. But then if we did, then we're checking to see if we got a first name, go ahead and set the employee that we found to the new parameter value, and the same for last name, and of course to that parameter value as well. And then we filter the array and we remove the existing employee record from it. So then we have an array with the existing, or I mean without the existing employee ID, and then we have the new employee data that we've updated here. So we go ahead and create an unsorted array, and we need to remember it's unsorted because we do need this array in chronological order by ID. And so when I call the set employees function from our data object, I go ahead and sort the array by that ID column. And this is a chain ternary statement. This is where it could look a little complicated if you have not worked with sorting arrays before. So we start out with the ternary statement here saying pretty much if the one element of the array .id is greater than the other, then return 1. And normally, if we were just doing that, then if not, it would be returning a -1, but we need to have a 0 if they're even as well. So then we chain this into another ternary, and there it returns a -1 or the 0 at the end of that. And then of course we send the employees after they've been updated by set employees. And that puts the array, the JSON array, back in the order we need it right there. Okay, scrolling up to get a little room to put in the code for the delete employee. When we paste this in, it looks very similar. We find that employee, but if we didn't get the ID, we send the 400 response just like above. We also create a filtered array just like above we did in the update. But then at this point, we've deleted the employee, so all we need to do is set the employees to the filtered array. And then we once again return the employees. And finally, the get employee. And of course, this is handling a request for the data of just one employee. So we find out who that employee is. And once again, if the employee doesn't exist, we send that same response that we did not get good data. But if the employee exists, all we need to do is return that specific employee. And then we're down here to the exports. So I will include all of this code inside of the GitHub repository for the end. This will not be the starter code, but the beginning. And then you can see this and compare to yours if any of my explanation did not make sense. And it looks like I've got an error here in the code. I think I missed the ending curly brace. There it is. They should be yellow, at least the way I have my Visual Studio Code set up. Tab that over and save, and all looks good now. Now I think I still have an issue here. The delete employee did not close out. If I close that out, then I can remove that. There we go. Almost had a bigger mistake that would have taken me longer to figure out. So save that, and now it looks like get employee, delete employee, update employee, create new employee, get all employees. That all looks like they're defined correctly, and there's no more error here in the file. Getting rid of the extra space, and let's go to Thunder Client, but we also need to go ahead and start the server up because I don't think we have done that yet. And with the dev server open, the terminal open, we'll type npm run dev. There we go. And start the dev server, and then we'll be able to test out our API. running on port 3500. That's what we needed. We'll open the employees API collection that I'd created in Thunder Client. And now this you'll have to create yourself, of course, if you haven't, but let's test get employees and see what we start with there. So we've got a get request, and we're going to the employees route, see the results, and we've got the two starter employees, Dave Gray and John Smith. Okay, now let's go to post, and let's post a new employee. And if we go to body, you can see I'm sending some raw JSON here. We're posting employee John Doe. We'll send that post request. There's a 201 created response like we wanted to send. And now we have John Doe here, and he has an ID of 3 as we expected him to. So now let's go to the put employee, and same route with a put request. We'll go to the body and see what I'm sending in the JSON. And let's change this. Let's update the second employee so it's right in the middle, and change his name to David. Now let's go ahead and send. And now let's look at our employees that were sent back. And yes, second employee is now David Smith, and they're still in the correct order. He did not get inserted at the end. It's not out of order. And so that all worked as we wanted it to. Now let's try the delete employee. And let's look at the body once again, what's being sent in the request. And we're going to delete employee number 3. So let's go ahead and do that. And now if we look, all the employees were sent back. Now we only have 2 employees once again. And now let's finally request an employee. This is get an employee, and we're going to request employee number 1. Send that request, and it looks like we received the information back for employee number 1. So all of our routes are working as expected. Once again, I'll include about the API to put in. I will have a tutorial, but if you don't have it, you should be. Today we will add use code. I will have a link to both.